Can you see my screen? Kevin or Jiayu?
Yes.
Okay. So this lecture is lecture 9, which covers the course package section 9 and 10. We discussed in the video lectures, we discussed the first order process and with examples about mixing and liquid level in and flow from the tank. And in the end, we talked about linearization. So before we go to the summary of this video, lecture, I would like to remind about exam 1, which is next week, Wednesday. During class time, we will have the question types that you have seen in the class activities and the problem sets. And it covers lectures 1 to 9, lab 1 to 4, and problem set 1 to 3. And it's open class, open notes, and you can use handouts, you can use course packets, everything you can use, but no smartphone use. So make sure that you don't communicate or discuss the questions during exam with your classmates. It will be a waste of your time. And you need to be on Zoom and open your webcam during the exam, and so that we can see what you are doing during the, just to make sure you are focusing on solving the problems in the exam. And terms introduced so far are provided on, in Canvas, and also previous year's sample exam is also provided in Canvas. You can find them. If you have problem finding them, either ask your classmate or shoot us an email. We can easily point you where to the location. And we have a problem set 3 due today, and immediately we will release problem set 4. Problem set 4 is not covered in, I mean, it won't be due before the exam. It will be after exam, which is October 19th. That is a Monday, again, before class. And also we have writing assignment 2 due by the end of October, and Kevin will provide more guidance on the writing after I do the summary for this lecture. So revisit first order systems. We have different type of problems that are first order systems, such as fluid heating system, temperature sensor, which we already introduced in our previous lectures. And today we will have more examples, such as mixing without reaction and liquid level in tanks and flow from tanks. So we only discussed non-interacting tanks. Non-interacting tanks and the interacting tanks. Some of them will be covered in later lectures. Also in the video lectures, we covered a simple resistor capacitor circuit problem. We won't include this in today's summary because of time limit. Also, at some point, we will have bioreactor problem solving, which again falls in the first order systems category. And example mixing processes like this, we assume non-interacting, well-mixed tank with flow rate Q, which is constant, and concentrations X and Y, and a known tank volume V. V again is constant. So we can, in the end, develop this first order differential equation to solve this problem, which is Qx minus Qy equals V dy over dt. I think you have seen this from lecture 8 when we talk about deviation variables. And to manipulate the equations, we put in the transfer function form. First, we need to subtract the steady state equation from differential equation to set up deviation variables. And then we need to define the deviation variables, and then we can write the ODE with deviation variables, which allow us to do Laplace transform. Also during this, we define the time constant. And in the end, we write the Laplace domain transfer function. So for this mixing problem, our time constant tau is V over Q. V is volume, Q is the flow rate. And the transfer function is pretty typical, which is GS equals YS over XX equals 1 over tau S plus 1. By dividing tau on both the numerator and denominator, we can get a new form for GS, which is 1 over tau over S plus 1 over tau. And then if we input a unit ramp function, which is xt equals t, which has the Laplace transform xs equals 1 over s squared based on the Laplace transform table provided in the course packet, we can get the final ys regarding a unit ramp input and the gs transfer first order transfer function. In the end, we get 1 over tau over s squared times s plus 1 over tau. And we can invert it by equation 24, which gives the following yt as our solution. And this is a typical graph of a mixing with unit ramp input. And we also introduced the mixing problem with other type of inputs, such as impulse input and sinusoidal input. And you can find the solutions for those, for using those inputs and the graph in the course packet. And next, we talk about liquid level examples. And in liquid level examples, we have 3 cases. Case 1 is when liquid level is the function of inlet flow rate and other constants. Case 2 is outlet flow rate as function of inlet flow rate and other constants. The third case is liquid level varies when outlet flow rate is constant. So basically when you read a question, you need to identify which, if it's a liquid level problem, you need to identify which liquid level case you're going to deal with, so that you can refer to different case solutions. So here, case 1 is where liquid level is the function of inlet flow rate. We assume laminar outlet flow, which is Q1 equals Z over R1. And to solve it, we are in fact building an equation Z equals the function of Q0, A, rho, and R1. And in the end, we can get ZS over Q0S equals R1 over tau S plus 1. Here, the time constant for case 1 is tau equals A times R1. So in the end, we can, so the transfer function, in the end, the transfer function, we can get GS equals K over tau S plus 1. And K is the steady state gain. And in case 2, again, the function is in a similar format, which is Q1 equals the function of Q0, A, rho, and R1. But this time, when we do Laplace transform, and in the end, we can get Q1S over Q0S equals 1 over tau S plus 1. So remember, case 2 is asking different questions for liquid level compared to case 1. And in this case 2, the time constant is A times R1. And in this course, we don't require you to deduct the time constant. We will provide a list of time constant for different problem solving. And we will show that in the end of the slide here. And the third case is when the Q1 is constant. Then we can take the Laplace transform and then produce the transfer function for case 3, which is ZS over Q0S equals 1 over AS. But in this case, it's not a first order response, which means we need to use integral in Laplace transform. And you can see the details in the course packet for the solution. So in the end, we get this ZT equals 1 over A integral 0 to T Q0T. And this is to summarize the 3 cases where we have the time constant figured out and the transfer function figured out. And this is the time constants for a different problem. For example, temperature sensor, we already introduced. Tau is rho times V times Cp over HA. And for mixing process and fluid heater, tau is V over Q. Mixing process is the first example we used in today's lecture. And in liquid level, tau is always A times R. And electrical RC circuit, the tau is R times C. R is the resistance, C is the capacitance. And you're not expected to derive the first order Laplace domain expression. So as long as you can identify the problem successfully, you can come back to the course packet or the slides to find the first order Laplace domain expression and directly use it. We may ask about the process in the questions, and you can use the appropriate first order Laplace domain expression and deviation variables. And any questions for this summary of lecture? If not, I would like to invite Kevin to talk about the writing assignment. So hopefully you get more guidance when you work on the writing assignment. And also this year we introduced peer review, which is new from previous years. And hopefully it will be very helpful to you because you are going to play the a greater role to give evaluation of your peers' writing assignment. Okay, Kevin.
Oh, excuse me, can I ask one question about the test?
Exam 1?
Yeah. So linearization with part 10, will that be on there?
Oh, yes. Oh, sorry. Somehow I missed that part. So the linearization is by Taylor series expansion, which is the same as we introduced in the calibration lecture, which is lecture 2 or lecture 3, I think. Very early one. Yeah.
But it might be on there.
Yes. It won't be covered. It won't be covered in exam 1, the linearization part. Yeah. Yeah.
So it won't be.
It won't be. Yeah.
Okay. Okay. Thanks.
Yeah, I will make sure I have several slides about Taylor series expansion for linearization in the next lecture. But yeah, Taylor series expansion is not included in exam 1. That's the last portion in lecture 9. I will send out an email about that just to make sure all of you are aware of that. Thank you for the question, Joe. Very important.
Yep, thanks.
Thank you, C. Hello, everyone. Kevin Yanni again. C has asked me to give you a little bit of an update on the writing intensive assignments. And so I'm sharing sort of the same PowerPoint that's used in the one video and with that. But let me give you an update. So the first writing assignment was due last week, and I'm working on grading of those. I grade those. Lenny handles all of the other grading. It takes me roughly about 30 minutes to grade each submission. So I am about 3/4 of the way through the roughly 40 submissions. My goal always is to get those back to you within a week, and I should be able to make that this year. So I'm going to try to get those done by the end of tomorrow, but it may just take me until Friday. I've been grading those in the order of their submissions. So those of you that submitted it later on Friday, yours are going to come about the last ones. Now, the other thing that's coming up here then is assignment 2. It's posted, it's available. The video describing it and the peer review process is also posted on Canvas site. It's in that writing section. There's a page that has all of the videos that I'm using for the writing of part of this. The submission portal is not open yet, but soon. Assignment 2 is a bit different. There are two deadlines and some multiple tasks with those. So now what I'm going to talk about here is not the same way the PowerPoint slide is. This talks about steps 1 and 2. I'm going to talk about in terms of tasks. So your first task is to revise your assignment 1 submission based on the feedback I'm providing to you. So some of you have major changes. Some of you have just minor little things and changes some things there. Be sure to look at the comments in the file you submitted. Not every comment that I've made is in the rubric. Some are just consider things, and some are you better do this. The second task is then to add to that this description about how 4 factors inform or revise your design. There's again a video about this that talks about this and why we're having you do this and a little bit about what that is. There's also information in the assignment, the file that's posted there. That name now is assignment 2 is due October 28th and reviews due November 4th. We're having you write about 4 factors that are listed in there in the assignment page. It's on page 3. You can also, again, listen to the video. It's number 5, factors to consider, about what I mean there. So we want you to write a little bit about those factors and then post that. And that is due at 4:30 p.m. on Wednesday, October 28th. Again, the details are in a couple of other places there. After that posting, within a day or so, you will be given an assignment to review 2 randomly selected classmates, what they submitted for this, and your reviews are due Wednesday, November 4th. So it's going to take a day or 2 to get those assignments out, but then you'll have about roughly a week to review those. There is a rubric. Here's roughly what's in that rubric is basically roughly 4 questions where you go and say, are the need and market clear and well described? Was the process description clear? Were the factors that the person selected clear and distinct, and are there what they described as reasonable with that? And then, were they well written? Your task in peer review is simply to comment on those. You don't have to give any numbers. Your comments should be constructive. Your comments should be respectful. And those are due then again Wednesday, November 4th with that. What I will do then is review your peer review comments, and then I'll grade those for assignment 2 for you. So those are the tasks for assignment 2. I will warn you that assignment 3 comes up pretty fast. It's due on Wednesday, November 11th. That's the one where you need to describe your sensor and actuator performance requirements. I'll get you more information about that soon. So let me know if you have any questions about the writing assignments. I've got my office hours are on Mondays after the class, but I'm available at other times, or send me an email. I've got one student that we're still trying to get the submission thing to work right, but we're making progress. So I will stop sharing. And